friends, this is Kaja Ramphari, bringing chemistry to life. I'm pursuing my BSc second semester from PG College, Kamarga. Everyone calls the assignment topic. Among this, I got the topic that is the soft acid, which is guided by Dr. Victor, Mr. Sanjay Agassi, Mr. Santosh Kumar Deharia Singh. Truly, because of their constant support and encouragement, we are moving forward in our life. This assignment is not just about gathering the knowledge, it improves our communication skills and it enhances our personalities. So let's move. So in chemistry, just as in life, everything do not bond with everything where the compatibility matters. Compatibility means suppose my two hands are two things which suit each other without any problem. That is the compatibility, right? Now, have you ever noticed in your life that we make a bonds with so many people like teachers, with our colleagues, with our parents? Not every connection becomes successful. And surprisingly, except happen with atoms. When we see the microscopic world, atoms choose their partner very wisely. Some makes very strong and rigid bonds, some attracted with the force. Chemistry is not just about reaction, it's about the relationship. And we today explore the soft side of relationship of chemistry. So this is the silent rule of nature of chemistry. So acid, we have to understand what is a hard soft acid-base theory is. So let us see some of the information. In 1958, the Allen, Chater and Davis classified two groups, Class A and Class B. In Class A, metal atoms prefers binding with the ligands such as nitrogen, oxygen, fluorine, whereas in Class B, metal has prefers binding with the ligands such as bromine, chlorine, sulfur. So what is the ligand is? So ligand is nothing but it is a donor. It donates the electron. After a year in 1963, Archie Pearson evaluated the previous classifications by creating a continuous spectrum of affinity based on a physical atomic properties rather than a rigid list. So he classified the three categories, that is the hard, soft and the borderline. Understand about this theory, we have to understand the two concepts. The first one is polarizing power and the second one is the polarizability. So what is polarizing power? It is the availability of cation to distort the anion. It is directly proportional to the charge density and inversely proportional to the size. Let me make you very simple for you. Suppose your smartphone is cation and you are anion. More will be the notifications, more will be you distorted towards it, more will be you attracted towards it, right? And due to its compact size, you can carry it anywhere. So more the charge density, more will be the polarizing power, more will be the small size, more will be the polarizing power. Now the second concept, that is the polarizability. It is the ability of anion to distort it towards cation. So it is directly proportional to the size and directly proportional to the charge density. Suppose imagine yourself, you're sitting in a cinema hall. Would you like to watch the movie alone? Or you will like to enjoy with your friends? What will be your answer? Of course, with your friends. So, more the charge density, more will the polarizability. And do you like to watch? Do you like to watch your movie in a smartphone, or do you like to watch a movie in a great cinema hall? What will be the answer? The answer will be in a cinema hall, right? So, larger will be the size, larger the polarizability. Now let us see which one is the hard acid, which one is the hard base, which one is the soft acid, which one is the soft base. So let us see step by step. Or the first we see, that is the hard acid. So a small size and the polarizing power here is higher, and it primarily forms the ionic bond, and the oxidation state will be higher here. If we see the hard base here, then electronegativity will be high. So what is electronegativity? It is the tendency of an atom to attract the shared electron towards itself in a covalent bond. And the polarizability will be low here. Now let us see in soft acid. Soft acid, so it should be large size, and the oxidation state is 0 or very low. Now the polarizing power will be low here, and they primarily forms a covalent bond. Now let us see which one is the soft base. So electronegativity will be low here, and the polarizability will be higher here. Now let us see some of the examples of it. You can learn through the mnemonics like लीना ने की रब से पर यार, बेटा ने मांगा कार स्कूटर बापराज, like that. Now let us see the examples of the soft acid, and that includes the heavy transition elements like Hg2 plus, Ag plus. Now borderline. So imagine your life. There are some persons that who can change their side accordingly to the situation. And do you know, in the Indian constitutions, in 10th schedule, there is the anti-defection law. If the person is changing their party or giving the vote against their party, they will be disqualified in the parliament if you watch it. It is amendment in the Constitution Amendment Act of 52 in 1958. So you can see here in the example of it like cobalt 2 plus, copper 2 plus, soft hard base, that is fluorine, oxygen, nitrogen, and here you can see the oxalate, this one. Now remember this one, most important exception. If you see the soft piece, then here is examples like sulfur, phosphorus, exception here you also remember here. Now let us see. Cyanide is exception in soft base, and borderlines. Here you can see the examples of. Let us see the principle of it. Before that, let me remind you your school things. Remember when you were in that standard, the third chapter of Sanskrit, there is one school which is suited for this topic, perfect for this topic. If you belongs to the city group. That is, मृगमृगे अनुप्रचन कौश्चकौस्तुरंकेस मूर्खे सुधिया सुधिभिः समानशीलं वैष्णेषु सख्यम. It means in Hindi, हिरण हिरणों के साथ, गाय गायों के साथ, घोड़े घोड़े के साथ चलते फिरते हैं और संगति करते हैं. उसी प्रकार मूर्ख व्यक्ति मूर्खों के साथ, बुद्धिमान व्यक्ति बुद्धिमान व्यक्ति के साथ. मित्रता हमेशा स्वभाव जिसके स्वभाव सामान्य होते हैं उनके साथ होती है. सेम दैट here the hard reacts with the hard and here the soft reacts with the soft. I hope you hear this word like dissolves and like mostly in chemistry. Going to the school days, there was a strict teacher. Everyone's lives there was a strict teacher in their school days. So your strict teacher is represent the hard acid and topper represent the hard base. So what do you think? A strict teacher, what it prefers? He wants discipline, punctuality, good grades. And which one will fit with him? Of course the topper. Do you think that the strict teacher prefers the backbencher who does not study at all? Of course not. Right? Similarly, it will make a stable bond. And if we just imagine a backbencher, they are very cool guys. So even tomorrow's exams, they're just wandering here and there, watching movies, going to cinema halls. I think that what they prefers, a cool guy or a topper, a bookworm who study at all day. The answer will be obviously the cool guy, not the bookish one, right? And that's make a stable bond with him. Imagine a moment, a hard acid and soft base. That means a strict teacher and the backbencher. The strict teacher with a backbencher, the backbencher is very lazy and making a reels during their classes. And so what will happen? Boom blast. Of course the teacher get lost. They will make a stable bond? No, they will unstable. Similarly, let us see. Now let us see the application of it, the stability of the complexes. As I already told you, you can see here, Ag plus is a soft acid and iodine is a soft base. It will make the stable bond. So it is stable. Now let us see the next example. Here is Ag plus is a soft acid and F is a hard base. So what happened? Remember strict teacher and a real maker. What happened? Unstable, right? Now let us see the next application of it. That is the affinitated ligands. Affinitated ligands are those that can donate the electron from the both sides. But they donate from the one side, but they can donate from the two sides, either from here or either from here. But they donate at one side. Here is the example. You can see thiocyanate. And here you can see it is the soft, sulfur is the soft one. So the padalliums are combined with here. Here you can see and it's a hard base. So what happened? It will react with the hard ones. So application, that is the geochemical or distribution. Look this, Mg2 plus, Al3 plus and Ca2 plus. Do you think that why this always present in oxidate and the carbonate forms? Why not in sulfide forms? The answer lies because it is hard. That's why. And they are the hard acid and these are the hard base. Similarly, here you can see the sulfides. They present in the form of sulfides like this one, and this one. He2 plus, He plus, Cu plus. The next application, that is the organic site preference. So this is the ketone and here is oxygen and here is the soft target. So the Gillard's reagent RMGX. So it will prefer the hard with the oxygen. Similarly with here is the soft site, the soft target. So the soft nucleophile will attack here. Nucleophile means the elements and the atoms which are the electron rich. Hard prefers hard and the soft prefers soft. That's why this one shows the hard and hard balance stable. In this image, the hard one reacts with the hard one and the soft reacts with the soft one. Now, activity power of this theory. You can see here the double displacement reaction. We can suppose CS plus. Then it will form. It is a hard one and it is a soft one. Similarly here it is a soft one and it is hard one. That double reaction, then what happens? Then Li plus CSI will form here. Hard prefers hard and soft prefers the soft. As we know that in this whole world, no one is perfect here. Similarly, it happened with this theory. Let's see. Yes, this theory said that hard prefers the hard and the soft prefers the soft. But look here, what happened? This one is soft and this one is hard. So it should be unstable. But reality, if you see this and this here, it will form a stable bond. Now let us see the next limitation of it. Here the H plus and H minus combine to form a hydrogen gas formation, right? And it should be a purely polar bond, but what happened in reality? It formed a covalent bond. Now, the next limitation of it, it does not explain the relative strength of acid and base. Which one is the hardest and which one is the lowest? Suppose, for example, the hard base fluorine and OH minus. It does not tell which one is the strongest. It's failed to explain it. In conclusion, I can say that this theory teaches us that the stability depends upon the compatibility, whether in life or chemistry. The strongest bond formed between the right partner. I mean, the partner means your friends, your colleagues, even the atoms. Choose your partner very wisely. Thank you.